Hello Bobby, welcome back. So in the last couple of lectures, we looked at the mobile phone, the battery, the charger, and looked at some electrical engineering concepts related to that. So why don't we go into something a little more detailed in this lecture?
Sure, that's very good.
Okay, so I mean, what is the primary purpose of a mobile?
Primary purpose depends on the person, but mostly it is to make a call.
Yeah, okay. So let's just look at the kind of operations that one would do if we were to make a call, right? So what would you do?
I'll make a call means I'll dial the number
Okay.
and then start speaking once the person.
Okay. So you essentially dial a number and then you start speaking and then you hear
The
what
response and then goes.
and you just continue and you disconnect eventually, right?
Maybe I didn't get you a question.
Yeah, so electrically, what are the fundamental operations that are happening when you look at these three operations, right? First is, maybe we can just list them down on the this thing. So first you're talking about dialing a number,
Yeah.
right? So which means you're taking your mobile and actually,
You are feeding in the numbers. For example, here there is a touch button through which you enter. the
okay, so this is of course a traditional landline, but in a mobile it would happen through a
a
touch
different-
screen, right?
A different way of
Yeah, so
sensing,
there is a
yeah.
touch screen where you're trying to dial a number and then you start speaking and of course you start hearing it, right? So, I mean, you remember these components that we dismantled, right? We had a mic here, we had a speaker here and so
Yes,
on.
Yes.
But these are so small that you can't even see what is in them, right? For you
Yeah.
to appreciate the functionality and how
Correct,
they work.
correct.
So maybe what I'll do is I'm going to set this mobile aside for now, right? And let's just focus on this traditional landline because it's just much bigger. The components are also much bigger out there. So if you look at this, it says mic somewhere down here, right? So even if I didn't use this particular device, I could use this to speak.
Yes.
And this is the speaker where I hear the response from.
Correct.
And I of course can dial my numbers out here and say call, right? So why don't we open up this landline now and see what is inside there by
Sure.
which these three things are achieved. Okay, so I'm going to now do the same thing here. So I have actually removed a couple of screws already, okay, because there's just too many of them.
It's an old phone itself, I think.
It's
Probably
it's an
some
old
screws
phone.
were missing.
Yeah, it's an old phone that's sort of not working right now. So it's useful for us to sort of dismantle and check, right? So I'm going to just take off these two screws. Okay, and as you can see, these screws themselves are much bigger than what we saw in that mobile phone, right? So these are the traditional screws that are available there. Okay, so I'm going to take this thing off and there you go. So this is a much more recognizable set of components, right? So let's just look at this before we go ahead and and maybe I'll also keep this mobile phone here with us, right, so that we can see, right? So what we see here is there is what is known as a printed circuit board, a PCB here. There is a PCB here also,
Correct.
right? And there are various ICs or integrated circuits that are sitting like a microprocessor, a DSP or something. Similarly, here in this landline you have a DSP here, and after that you have capacitors, you have resistors and so many other things sitting on this landline. Okay, so just if you look at this again, you press a button here, something is going to happen in the background by which the PCB will recognize through some electrical signal that we have pressed 3. Okay, that's what we are going to first start with. Okay, for that I also need to dismantle this
see the other side of the PCB.
I need to see the other side of the PCB, and here again I have already removed some screws. Okay, I'll take this mobile off. I'll just keep this screw here, and there's just one more screw that I need to remove, right? And I can now take this guy off, right? So this is slightly complex. So you know, this is actually a very old mobile, so I'm going to risk and cut this cable off. Okay, so let me just,
Or
maybe I can remove this also, right?
Yeah.
That's actually a good idea.
The screw type is different.
Yes, yeah, but it's okay. It's still, you can get it out with this. Yeah, right. So we have opened it up completely.
Oh, there are nice figures here.
Yeah, there are nice figures here, and what you see is, you know, the number 1, 2, 3, 4, 5, 6 and so on, corresponding to these buttons that we had here, right? So when you press a button here, there is something that gets pressed out here. So if you can go and apply some pressure here, it is equivalent to actually saying that one.
Actually this black color part.
Yeah, so you're saying,
which is a conductive part.
This black color part is a conductive part.
It's a conductive part.
Okay.
That makes connection between the inside star and the outside portion.
Okay, so you essentially, you're closing that switch.
Yes.
By which you recognize that one has been pressed.
Yes.
And that's the number. Yeah. Okay, so electrically that's what is happening. So a switch.
It's a closing a circuit.
Closing a circuit somewhere. Okay, so that's how the button press is recognized.
Yeah.
In a mobile phone, it's slightly different. You have a touch screen, right?
Yes.
So
mostly a capacitive-based touch screen.
Okay, so maybe we'll look at that a little later, right? For now.
And why this flower symbol?
Oh, that's an interesting question. I have no idea.
Probably, you know, the contacts, even if there is slight movement little bit here or there, still it makes contact.
Oh, so it's just like even if some error is there, you still get a clean contact out there. So, okay, so that's why you have these flower kind of symbols here.
Well,
okay.
The probability of switch working is better with this.
Is very high. Okay, and yeah, absolutely, yes. So that is something that you need to consider when you are looking at a design.
Yes.
Because people are not going to press it in exactly one way.
Correct.
Right. Okay, so now let's come to the second part. You have dialed a number and you want to start speaking. You want to say hello, and the hello has to get recognized, and you know, it has to get transmitted to the other side somehow. So
whatever I produce here, this waves has to reach some sensor.
Okay.
And then that has to convert into electrical signal.
Okay.
So that you can.
Okay. So
on a surface level.
Right. So you're saying that whatever I speak is coming out as sound energy, right? As sound waves.
Correct.
And that has to translate to some sort of an electrical signal. So what is the gadget that does that for us?
There are multiple ways of doing that, but on a basic level, let's say if you have a thin diaphragm here,
okay,
and if you are speaking,
that
diaphragm will start vibrating in the same fashion.
Okay.
And somehow if you can convert that vibration, that movement into an electrical signal.
Right.
So that second part can be a magnetic sensor or a capacitive sensor and so on, which we will study later in some of the courses.
Okay. So, so that is essentially done by this particular component here, which is the microphone.
Yeah.
Right. So there is a diaphragm here, which is going to respond to our voice signal.
Yes.
Okay. And that is going to give out some sort of an electrical voltage. Okay. Right. So that's the microphone, and you know, you say hello and the other person says hello and you have to listen to that. So similarly, there's a microphone at that end which picks it up, does something,
Yes.
Electrical signal is sent over this side, but how do you hear it now?
Through the speaker.
Okay. So, and if you remember last time I gave you this thing, you put it here
Yeah.
and you will see it's a, there is a magnet
Correct.
that is involved in this particular speaker here.
Exactly.
So actually I'll do one thing, I'll maybe even remove this. There's no harm in removing this. You see these screws are magnetized already.
So what we see is two wires
Okay.
going into the speaker. That's what we see for now.
Yes, we just see two wires that are going to send some current or something into that,
Yeah.
and that is going to somehow magically produce the sound that we will hear. Okay, that's a great thing, right? So what you see here is a lot of dust, but it's an old phone. But otherwise, you know, there is a magnet inside this. There is, like you said, two wires, right? And there is some diaphragm again on this side,
Yeah.
right? So can you just explain in slightly more detail how this speaker is actually going to work?
So basically, the diaphragm has to move
Okay.
and produce the same kind of waves so that our diaphragm senses it.
Oh, you're saying the ear also has a diaphragm which is going to do some sort of translation,
Yes.
signal translation,
Yes.
by which the brain will understand.
Correct.
Wow, okay. Okay, so how does this particular thing actually produce a sound? Let's say I send some electrical current through these wires, okay, and that has to translate to some sort of vibration that we are going to hear. So how is that operation actually going to happen?
Yeah. In a very simple way, we will look at it. So I actually have a better, figure here that can be used for explanation.
Okay,
So this is basically a cut section
okay.
of a similar type of.
So in the
speaker.
sense, I cut it like this
Yes.
vertically,
Yes,
right?
yes,
I
yes.
cut it and then look at it from the side.
Yes.
Okay,
Yes.
great.
So you see the diaphragm here.
Okay,
That's one in the top,
okay,
and then the current that we are sending
okay. Through these two wires.
is
Yes.
flowing through something
Okay,
that is visible here.
yeah,
You see a coil.
yes.
So it's a coil.
Okay,
This coil is able to move up or down.
okay,
How? Because you are sending the current through the coil,
okay.
and then the coil is present in a constant magnetic field.
Oh, so that's why you need that magnet.
Magnet there.
So that magnet is needed to produce a constant magnetic field, and that translates to the magnetic force of BIL,
Yeah, exactly.
right?
Exactly.
Which we studied in our 12th standard, right?
Exactly.
It's originating from Biot-Savart's law.
Yes. So basically,
Okay.
you are sending that current I through this coil,
While, okay,
and depending on the frequency and magnitude of the current,
okay,
the amount of movement is happening.
okay,
And this coil is mechanically linked to the diaphragm. So whenever the coil moves, the diaphragm also moves.
wow, okay.
So it produces the waves, we picks up.
And okay, so that diaphragm actually perturbs the air molecules. That air molecules actually come eventually to our ears
Yes.
as a wave, and our diaphragm picks it up
Yes.
and sends it to the brain.
Brain.
Wow. Okay, that's very interesting. So thanks for that. And so now let's come to the microphone, right? A little more specifically, the microphone. Obviously, I can see that it does the opposite job, right? What you speak, it does some. Though I don't know, like you said, it could be magnetic, it could
Yeah.
be capacitive,
Yeah.
right? It could be different ways of.
So if it is magnetic, it can be very similar system.
Okay.
So the just opposite of this.
Okay.
Let's say you are moving the diaphragm up and down.
Okay.
Then the coil will also move up and down, which is moving in a fixed magnetic field. So there will be voltage induced in that.
Oh, that is the electromagnetic induction that you're talking
Yes.
about.
Yes.
Through Faraday's law, you basically are able to generate
That is one way of.
a current which is now proportional to the diaphragm's force
Yes.
that is causing it to move up and down.
Yeah.
Okay, interesting. Okay, but as usual, I have one question for you.
Hmm.
How do we know that all this is true?
We will have to cross check it actually.
Okay, right. So what we'll do is, first of all, let's just look at this PCB a little more carefully. On the other side, so what you see here, Bobby, do you see this? It says MIC.
Yeah, so
right?
the terminals of the mic.
Yeah, terminals. So one big advantage of these large PCBs is, unlike these mobile PCBs, right? You are able to at least write something which you can understand, and you can actually, so it's actually possible to even understand what is in this PCB even though you did not design it, okay? So what you see is there are two terminals, okay?
Yeah.
Just like on the speaker, we saw that a current was sent through two terminals, right? You are now looking at a microphone which is giving you two terminals, right? So there should be some output
Available there. Yeah.
right?
Yeah.
And it should be an electrical voltage or current,
Yeah.
right? So why don't we go ahead and first, sort of look at this a little more carefully. And well, till now the only measurement that we have done is through this multimeter or voltmeter. So let's start with that. Let's see if we get anything out of it, okay? What I'm going to do is, first, I'm not going to connect any power to this PCB, okay? So there's no battery that is controlling it, nothing, okay? I'm going to reverse it, okay? And I'm simply going to measure how much of voltage you're going to get across these two terminals.
Almost zero.
Yes, so you see that this voltage, right, is, so can you just hold this here, right? I'll again place it, you might want to place it, hold it here, okay? I'll connect it again. It is sort of falling off to 1 millivolt, 2 millivolt, down to 0.9, effectively 0 millivolt, okay? So there is no potential difference between these 2 points if I do not connect a power supply. Okay, now what I am going to do, okay, is I am going to let me just get this out of here. Okay, I am going to take an adapter, by the way, and this is a 12 volt adapter, by the way. Okay, and just to,
do you want to check that also?
we can do that. Actually, that's a great thing. So let us, as usual, let's not believe anything. We will go ahead and check this voltage. So can you hold this up here? I have essentially connected it to the adapter.
12.1.
You see that it is about 12.19 volts, right? So this is, we are convinced this is right.
So the meter is also working.
Meter is working, and things are good. Okay, so now I am going to connect this power supply into the PCB, right? The PCB power supply slot, right? And I need to, of course, ensure that there is power supply coming here. So I am going to look at the other side of the PCB, right? I will just, can you just hold it? Yeah. And I will probe these 2 points on the other side. So you can see that that is 12 volt.
Okay.
Right? So maybe you can just hold this up. While just leave that down. You can leave that down. Yeah. Just hold it up. And I will just look at the voltage across. It's 12.18 volts, right? So there is some power appearing here, right? And now what I'll do is I'm going to look at the output of these two, of the mic points, these 2 points here, electrical points on the PCB, right? I'm going to look at this here. Yeah, so you may want to hold it up for me. So this is going, check. So this is doing something funny, right? It's at some 89 millivolt, but it is changing with time, right? So
meter seems to be not good.
Is the meter not good, or is this not the right way to measure this, right? So
this is an, you are measuring the DC voltage.
Exactly.
So this is the average voltage, whatever.
Exactly. So what is happening is, in the last couple of lectures, we were always looking at voltages that were fixed over time. The battery gave you 3.8 volt or 5 volt or 12 volt, whatever measurements we made, they were just fixed over time. So it did not matter at what time instant you measured it, right? But what is happening here now is what is being produced in this mic seems to be a time varying voltage. Right, you're getting not a DC voltage but a time varying voltage, and of course it's going to have a different voltage at every time instant, and that's why you see this meter also fluctuating so much, right? Which means that this is essentially not the right instrument
To observe this.
to observe the output of such a microphone, right? So what we'll do in the next lecture is we will look at a microphone in isolation, and we will also look at the time varying output that is coming out of such a microphone and analyze it for
What kind of waveform?
What properties it has, and how you can actually quantify certain, numbers.
So the electrical signal that we mentioned earlier, the electrical output corresponding to the waves,
Yes.
sound waves,
Yes.
we will be able to see.
We will be able to see. So if you speak louder, what do you expect? An
More,
increase in amplitude, right? And if you change your tone and start speaking like this,
more wave.
you will get a higher frequency, right? We will see if all these things actually come, reflect in that time waveform that we are looking at.
Let's see.
Okay, thank you.